So, welcome everyone. Yesterday we are able to go over what we did last week, and we concluded it with uh, testing yesterday. So, Daniel, I think your mic is unmuted. Did you have something to say? If not, I would then mute it. Okay, just so we are not distracted. So, welcome once more, everyone. Yesterday, as I was saying, we had our class based on the module, a revision on the module, a revision on workspace. But yesterday's class was basically majorly based on, testing. And before we had the class on modules and workspace, I made mention on Thursday that on Monday, we would have like a classwork, like a class assignment where everyone basically on the call here, we would basically have the classwork. But unfortunately, because we could not finish the lessons on modules, workspace, and testing, so we completed that yesterday, and we had questions trooping in, which was quite great. And so for that very reason, we completed the lecture yesterday. And I made mention that in today's lecture, we would instead be having a class assignment. But still on yesterday's lecture, I would want to have more like a review on testing, as testing was the major thing we spoke about yesterday. So I'll be doing like a short review on the testing we did yesterday. So yesterday we were able to talk about what testing is in Rust. We spoke about the different tests we have. We have unit tests and integration tests, documentation tests. We made mention that unit test basically allows you to test individual functions in a library. So if you have a list of functions, you can create so many tests on that function. Integration test basically is a way you test so many libraries that uses other libraries. So when you have like a workspace and this library is using this library and this library together are being used by a major crate. And so this major crate, you then test from there. That's basically integration testing. Integration testing is the ability to test a whole lot of projects simultaneously that are being used together. Documentation test is literally test code examples when you are writing your documentation. And I, in fact, showed it from yesterday's class that, okay, when you have a documentation on a crate that you have pushed, you can basically test and show how the library or crate is being used by creating a test for it. And that is exactly what documentation test is. I then proceeded on to showing us how to write tests. And in fact, we wrote some tests yesterday. And from yesterday's class, Valentine asked certain questions concerning, testing from main and testing with, the test formats, and I showed. And those questions were answered well, and everyone was able to, to gain. I also went on to explain that you can test a single function multiple times with multiple ways. You can test a single function to do so many things simultaneously. And some of these tests for that single function could pass while others failed. And I gave example of a test that could fail yesterday. I made mention that the assert equal is one of the macros you used for testing. I also made mention of the assert. Assert is another macro you can basically use for testing. So integration test, I discussed that when you are using a library for another library, and then you basically test the full code base, the full workspace together simultaneously. That's more of integration test. So just to complete this, I also explained that although I did not say what I'm about to say yesterday, but I just gave brief to it, how to basically run your test file. You basically run cargo test. Yes, that I explained yesterday. But I never spoke about running a specific test. So if you have a group of tests, in fact, I'll stop sharing my screen, and I think I add some test files that we worked on yesterday. So I'll just show from my screen how it's easy to basically, test whatever. So here are the files we had yesterday on testing. We created 3 different tests. And so to test is a particular just all the command. You can run cargo tests to test everything. It basically run the full test for you. And here are the tests, the 3 tests we have here, the it works, check, and check test assert. These are basically the tests. Now, what if you want to test just one of it? You can basically run cargo test. See, we ran cargo test, and in this case, I wanted to test for just the check assert. And so I added the check assert in front of it, in front of cargo tests, check assert. And for that, I was able to run just that particular test without running everything. And yes, the test actually passed because our function add, when you assert it to add both this -2 and -2, it definitely should give -4. So yeah, that works basically. So going back to it, you can basically also ignore a particular test. So if you're running a test, simulation, and to do that, all you need to add is this #ignore. Yeah, ignore. There's no need for us to add the reason. You just add ignore. And right now, I'm just going to run the full test, and notice that this particular test will be ignored. So if we scroll up, can you see 2 passed and check assert was ignored? So that's out. So you might have certain tests you are working on, and due to certain reason, you believe that the test should fail currently, but then you might not want to, work on what it's failing on as at that time. So you could just write out the test and ignore it. You could ignore it and continue with what you are doing. So this basically allows you to what? To ignore a particular test, just like you can see here. So going on, you can also debug test failures, a situation whereby your test is failing. One important thing you can do is you can print it out and you can debug it. So it's a general way of debugging, basically, when you have to, print out every single line of code for you to see where or what is going on exactly. So one thing you can do is you can use this macro dbg to debug your tests, and also you can basically use println. It's something you can basically use to always just print out to the console where and what is going on in your test. At the end of the day, the most, as I said yesterday in yesterday's class, I made mention that the most important thing while you are testing is for you to ensure that what you ask your code to do is what your code is doing. So when your code now starts misbehaving, obviously you want to know why and where it is misbehaving. And so all of this is basically the print line basically allow you to, print out every single part you want to print out for you to debug that, okay, this part of the code is where it's messy. So documentation testing, I've shown the example. And then best practices, always organize your code in logical modules and use visibility effectively. And this is very important when you are talking about modules. I explained from previous classes from the back time, it would seem like I repeat a whole lot of things. It's a very important thing. When teaching, it's quite important that you repeat so it sticks to the brain. And that's exactly why I would keep repeating so many things I've spoken in last classes. So use Workspace for larger projects to keep related crates together, obviously. Write meaningful tests with high coverage and run them regularly, and then document your code well. So this basically covers everything we have spoken about when it comes to modules, Workspace, and tests. All of this is just going to serve as more like a reminder to what was discussed in previous classes. But the major aim for today's class is this. I'll stop sharing my screen and, in fact, reshare it again. I'll stop sharing it and reshare what I want to share to be what we'll be majorly doing in today's class. Yes. This is what we'll be doing in today's class. Implementing a library management system in Rust Workspace. Yes, we have basically done a library management system. We have created it before. Yes, we have created it before. But then, why exactly are we doing it again? And what then are we doing differently? Now, we are now going to, when we created the library management system before, we did not add so many features to it. And for that reason, it was on a minimal level. And if we can remember from that particular one, we spoke about few methods that we added to we'll be creating a Rust workspace containing multiple library crates and in binary crates that simulate a library management system. What are the things we'll be learning from this? First, we learn how to work with a Rust workspace. So what we have explained, what we have taught, we will learn how to use it. Two, when we worked with enums and we did not have like a practical assignment or class work to work with enums, and for that very reason I had minds of adding it when we are having a practical work on workspace and modules. So we would be making use of enums and structs for modeling. Then we would also then be implementing unit tests. So we would be implementing unit tests for all of this. And then lastly, we would create modular code by splitting the functionalities across multiple crates. So obviously, I won't be the one to start this. It's definitely going to be a class assignment. And yes, I'll be dropping the class assignment here. So, yes. So what would this project structure look like? The project structure would be 3 different libraries. We would have an inventory library, we would have a users library, and we would have a borrowing library. Then lastly, the major app would be the library app. Okay, is there a question? Oh, it said the network is quite bad. Oh, I'm sorry about that. Okay, so we, unlike the last one whereby we had just a simple library where you remove, you edit, you add, and all of that. Instead, today's own, we would be having something bigger and robust. And that is exactly what the classwork could be. So for the inventory library, the inventory library will be responsible for managing the collection of the books. So to start, you definitely have to define a book struct with fields like title, author, genre, the ID, and the availability if the book is available. Then you have to use an enum for genre with variants like fiction, non-fiction, science. I'm sure Ogaski might definitely remember him talking about me adding something like this if it's possible to add it. So yeah, I thought about that and definitely I included that. I'm not sure it's on the call right now with us right now. So I definitely thought of adding that too. So for the inventory management system, it would have all of these. It will have an enum for the genre, and the variant would be either a fiction, a non-fiction, or a science. Then it would also have different methods that you would be implementing for these book structs. So for the book struct, you would have to add a book, to remove a book, then to inquire the different book if it's available or it's not available. Then for the second library you'll be creating inside this workspace, what would the second library do? It will be a library that manages the users. So it will be like a users library. So the users library will basically manage the users, people using and coming to the library. So what you want to do is more like a functional application for a real library. So a functional application for a real library where you can add then you can basically have the users come there and borrow the library. They enter their ID and then they check if they have the access to, to borrow these books. And if not, then they basically, have to register to borrow a book, just like you would have in a traditional library. So we are building this application for that library. We are building the application. So this particular module, the lib for the users, would manage the users of the library. So for that, you have to define a user struct with fields like ID, name, borrowed books. That's a list of the borrowed books, and it should include the IDs of these books. So basically, it's more like managing users that are borrowing a book or users that are literally lending and trying to get a book from the library. So then you have another lib that handles all the borrowed all the borrowed books, I mean. So what would that lib be doing? It would handle the borrowing logic, and it uses the lib inventory and lib users. So what would you be doing? You would implement functions to borrow and to return books. You would also include validation for whether a book is available and if the user can borrow more books. So you can have a maximum threshold for how many books the user wants to borrow. You can say, okay, fine, I don't want the user to borrow more than 2-3 books at a time. Unless they return a book, then they can come back to, to borrow another book. So you must have already implemented the function to borrow and to return books. So you would include that validation for it. So the last part of the app would include definitely the main.rs. The main.rs is going to be the binary crate, and it's going to bring the entry point to the application. Just like I tried explaining to you, Valentine, yesterday, the main.rs for this particular assignment you are going to be doing would be the entry point or the binary crate that would basically use all of these libraries that you have created down. And when I say library, and we are literally building a library application, it kind of clashes, but I hope you try to understand the kind of library I'm saying when I say library and when I use library in the different contexts. So there are two different things, basically. So the binary crate would use all the libraries that we've listed up, the inventory library, the users library, the borrowing library. It would basically use all of this and it would simulate a library management operation. And lastly, one thing I have not taught or explained is how to create a CLI interface to interact with the system. So definitely as a developer, one of the important things you have to know how to do is research. So yes, on the call, you cannot, or obviously you would not be able to definitely finish this application, definitely. And that is exactly why you have both today, tomorrow, and then Thursday when we come together again for this class to, to work on it. Then we can then come to the class on Thursday to have the solution to the assignment. And don't get your mind rest assured that we are gradually moving to working with the Soroban smart contracts, basically. So moving on, you would definitely create a CLI interface for interacting with the system. And lastly, testing. Each of these libraries you are creating, the inventory library, the users library, the borrowing library, all of them would basically have unit tests for its core functions. So all of these libraries would have their own unit tests inside of it. So you can test one function more than 2 times or using like four tests for it, writing 4 tests for the function. Then for the last one would be an integration test. What would the integration test look like? You would write an integration test for scenarios like borrowing a library, borrowing a book, and ensuring that the user and the inventory are updated correctly. So that means that person definitely, your test would cover where the person is coming to register. The test will cover the person borrowing the book. So don't forget, registering borrowing the book would mean the book has already been added to the library. So that is exactly what integration test does. Now you can see or have idea as to how all of these things are connected together. So the integration test is literally testing methods inside the inventory library. It's testing method inside the users library, testing method inside the borrowing library. So all of these things come into the entry point, which is the library app. So what you're doing, your integration test should now test all of these core functionalities. So when you're writing the integration test, obviously inside the test, you will have that the book has been added to the library. You will add that a user has been added to the users of the library. Then you will then add that, okay, the user is borrowing before you now create your test where the user borrowing cannot borrow up to a maximum amount that you have specified, or you create your test whereby the user must return before he borrows. So you can create the test whereby the user actually returns it and is able to then borrow again. So basically, you can create your test anyhow you want it. You create different scenarios for the integration test, and creating these different scenarios for this integration test will basically do something. It would allow you to, have access to testing all your different methods, just like I've said, for it inside one test. So what are the instructions? Set up the workspace by defining it in the root cargo.toml, then implement each crate according to the specified functionalities, then ensure the lib borrowing depends on the lib inventory and the lib users. Then write tests in each crate and ensure all tests pass using cargo test. So this is basically the classwork stroke assignment that I have created for everyone to work on. So looking at this project structure is definitely how your project would look like. The library management is the main directory of the project, or that's the folder name for the project. Then you would have this cargo.toml. This cargo.toml here is what would include your full workspace. where you would have the members, and the members would include inventory, users, borrowing, and library app. So all of them would be included inside your cargo.toml members. Then inside, after doing that, then you do cargo new dash dash library, and then you add lib inventory. And for that, you will then have this structure. Then next, you will do the same thing for this. Then next, you will do the same thing for this. And then next, you will do the same thing. But for this case, you would not use this one as a library. And in that case, you would not be able to import this inside this or inside this. But you would be able to use this one inside there and inside there. And then this one's simultaneously like that. So is there anyone that have any question based on my explanation of the assignment? You can raise your hand now. If you have any question based, okay.
So you said something just now. You said the lib inventory. We're going to import it into the lib users and the lib borrowing and um I don't know. Is that what you just said?
Okay. So I was trying to explain
Can
that.
you hear me?
Yeah, I can hear you. I can hear you. I don't know if you can hear me. You can hear me, right?
I can.
Okay. Yeah. I'm saying that the lib app itself is a crate. And due to the fact, it's exactly what I was explaining to Valentine yesterday, that the lib app, due to the fact that it's a binary crate, the entry point, it is main.rs. For this reason, you cannot import main.rs inside of lib borrowing. But notice that lib borrowing is lib.rs. And for this reason, you can import lib.rs, this lib borrowing inside lib user, inside lib inventory, and simultaneously for lib inventory, you can import it inside lib user and lib borrowing. When the instruction given here is for you to ensure that lib borrowing uses lib inventory and lib users. What that means is the crate you are creating for this lib borrowing, it would basically import both lib inventory and lib users. So that's just the idea. Did you get that?
Yeah, I
Okay.
did.
Okay. Are there any more questions on how to go about with this class work? Anyone with any question? Okay. Okay.
So then the this lib library management is, as we all have this lib inventory, the lib users and the borrowing, lib app, everything's inside this lib library management. So what will be in the tmfi cargo.tmfi
For
event?
this, for this lib management,
Yes.
that's exactly what I explained earlier. Inside this cargo.toml is where you would have the workspace, and the workspace would include members. And what would be the members? The members would be the lib inventory, the lib users, the lib borrowing, and the library app itself.
Okay. Thank you.
Nice question. Does any other person have any question?
But wait, it seems we have two cargo.tmfi.
No. Rather, you have
Yes.
so many cargo.toml. Oh, sorry. This
No, I mean the
cargo.toml, yeah, I can hear you. This cargo.toml is for this main.rs. This is the workspace cargo.toml. So each of these crates have their own cargo.toml, as you can see. Each of these crates, they all have their own cargo.toml. So this library app, this is its own cargo.toml. This is the workspace cargo.toml. So does anybody have any more questions? If no one have any more question, is everyone clear on how to start their own part, how to start the full project? Is everyone clear as to how to start their full project?
I've got one question.
Okay, I'm listening.
Because like you've got multiple cargo.toml, can we just like
Yeah.
copy the first one that we get when we do the cargo new in the command line and just,
Okay. Okay. So to answer that, on this call, just to make it easy for everyone to start working on the project, I am going to work on the workspace and I'm going to show what the workspace would look like. So I'm going to create it on this call. But before I create it, I think Cogsy has a question. So let's listen to her. I think she raised her hand up. Cogsy.
Sorry, I think what I wanted to just ask before was concerning the testing. I don't know if maybe when you were explaining it, I couldn't hear you. My network was not good at all. So I was asking if you explained how to test yesterday, and one way you explained was not using the main but using the test macro instead, right? That's how we're going to write our test, right?
Excellent. But now in this case, you are not just going to write the test itself for these libraries. Rather, you'd be writing integration tests too. So you write both unit tests and integration tests. Unit tests would be tests inside of these different crates. So for your inventory crate, you would have a unit test inside the library. For your users crate, you would have a test inside it, the unit test. For borrowing, you would have a test inside the lib.rs. But then for your library app itself, which is the entry point of your program, you are going to have what we call integration tests. This is because inside your main.rs for here, all of your libraries that you have used, both the inventory, users, borrowing, everything will be used inside of this library app. So whatever you are testing here would definitely then be an integration test. Does that make sense? Ah,
No. The integration test part, I don't really get that part.
okay, no problem. I would have to
Is
explain
it
what
like I don't get that?
okay, no problem. I'll then have to explain what integration test is all over again. So what exactly is integration test? I'll stop sharing my screen and then I would share my full screen. And then I would use this to explain what unit test and what integration test is. Now, we are inside of this crate back end, as you can see. We have just one function inside this crate, add. Now we have our test file, our test here. Now this test includes 3 different tests. All of these tests are all unit tests. Why? This is because the test is only testing just one function, as you can see here. It is testing the add. It's testing the add here. It's testing the add. So you can definitely write or add more function and let me add more function. The fact that I said it is testing just a particular function at a time. So this is what I'm talking about. So you can basically create another test here. What the test does is it checks for the sub, and then once it calls it, it runs. So it's basically tests for the subtraction. 2 minus 2 should be 0, and that's what it's testing for. So now you can have all of these tests. You see, we have 3 tests for just the add. We have just 1 test for the sub. But at the end of the day, all of these tests are all unit tests. They are all unit tests. But now, imagine we now have, I'm going to add something, and I'll add it cargo new, and I will call it main app, or yeah, main app. So if I add this cargo new main app, notice that inside our cargo.toml here, main app will be added to it in the workspace, and the main app crate will be created here. And instead, inside this one, we would have main.rs inside it. Now, you can now have so many of all of these functions that you are using inside of these different crates imported here. So you can use all of these functions imported here inside this main, and then you now create a test for it here. So you can basically create a test for it here and use every single one of it here. Obviously, this will throw an error because I've not imported this yet. But you can now create a test and integrate all of these libraries that are being used everywhere. You can then create a test that will use it here inside of the main. And this then becomes the integration testing, whereby this library using this library using this library is then here to create more like a function entry point that basically tests all the scenarios. And then, okay, Valentine.
Just a question, like let's say
Okay.
you had the main, and then you had all the other modules, and then in the main you were to do like mod library users, mod library inventory type of thing. Like, why would you do it this way? I mean, this way instead of doing it like that way, if that makes sense.
I didn't get the question. Can you come again with the question?
Because like I've seen in a way you can do it where you can have it in one like folder, so you don't have multiple tomls. And what you do, like you have your main folder, but then you call in all the other modules you have by using mod and then the name of the module that you're using. And like in that way, like you have the whole app in under one toml, if that makes any sense. But this one, like you've like split it up, and I just want to know like why would you do it that way instead of the other way? Because I know that you can make like multiple folders, but I just don't know why you would do it and have multiple tomls. Yeah,
Why I would do
sense,
it
really.
because of larger application. Now, all we have been doing is very, very minute and small. There are very, very big infrastructures that basically have so many things in it. Maybe I should look for one of my code base that I'm working on, and then I would show you a Rust code base. Yeah, I think I'll just increase the screen. Why I'm showing you this code base is because I want you to understand what working with so many multiple um, projects looks like. Now, I'm just going to use this as an example of what I'm talking about. Now, this particular project is a ZK proving system. And now in this ZK proving system, I have different proving systems. I have Shamia secret sharing. I have some check. I have GKR. Have I added the GKR? I have the
Oh, you're not
flag.
sharing your screen.
I'm not sharing my screen.
No, you see what screen is that the new one's not showing.
No one is seeing. Is everyone still seeing my screen? What are you seeing right now?
Your
The
screen,
backend block.
the infinity screen.
Sorry, Nomad, what were you saying?
It's just the infinity screen we're seeing right now, like all of your screens like in each other.
Oh, now, how about now?
Now we see the coding.
Yeah, you can see ZK stuff, right?
No, I think this is like the class example. I could see the ZK stuff before, but it wasn't in full.
Maybe I should stop sharing my screen and then start sharing again. Okay, so how about now?
I think it's like to the left of you, the one that you want to show us for the example. Like we can see the coding now, but this is like the class one, not the one that you're working on.
Maybe I should
Yes,
leave
we
the.
can now. We can see the class screen right now.
Yeah, we can see the coding screen.
Maybe I should leave and join the call back. Probably a network glitch issue. I'll leave the call and join back now. Okay, so I'm back and yeah. So I'm sure everyone can see the ZK stuff, right?
Yeah. Yes.
Yeah,
Yes.
yeah,
Can see zero
perfect.
stuff.
Okay, great. Now I'm going to use this as an example to explain to you why you want to have so many folders and so many projects for different things. So now I'm working on this project where it's literally cryptographic proving system. And so I have this particular crate that creates multilinear polynomials. And inside these multilinear polynomials, I have all my functionalities here in it. Yeah, as you can see. As you can see. Now, this multilinear polynomial, okay, I have my test for it. Now, I also have inside of these polynomials, I have this univariate polynomial. Now, it's a different module, as you can see. It's a different module for the polynomials, and it's under polynomials. Now, where am I going to? I'm going to come here to this Shamir secret sharing. Now, this Shamir secret sharing is a cryptographic proof, basically a type of proof whereby you want to share. It's usually used especially for when you want to have like a key sharing system whereby you want to have a threshold of probably 3, and you have 5 people that you want to be able to sign a transaction, and then only 3 should just come in consensus to sign the transaction out of these 5 people. If any of the 3 is available, then the transaction can be signed. So you can basically, with this Shamal secret sharing, create keys for all of these 5 people, and it uses elliptic curve to basically, get the keys to be shared. So now for this, I needed my polynomials because I wanted to use a univariate polynomial to do this. And so because I have this univariate polynomial on its own, standing alone, I can basically use it inside of this Shamar secrets. Let me close some of it so I can increase the screen. I like basically, splitting my screen because I usually have it on a bigger desktop. So this Shamar secret, I can basically use my polynomials. Can you see where I used the polynomials? Yeah, that's the univariate polynomial because it's a different crate on its own. Now, this univariate polynomial, I can now use it also inside of this Shamar secret. Although I did not use it, but I can also use it inside of this Shamar secret. But then I actually used it inside of this sum check. If you go to provers, you definitely see me importing my multilinear polynomial. Now, obviously in the Shamir secret, I made use of the univariate polynomial. But due to the fact that I organized all of these crates in their own projects, it is easy for me to import and use any of these crates wherever I want to use it in a different project that is related. And so if I publish this crate, anybody that wants to use any of these particular crates inside it can basically use it because they are interconnected to each other. So does that make any sense to you, Valentine, based on what I'm trying to say and why it's important that you have all of these projects together?
Yeah, like when you're making bigger projects, like it just makes
Exactly.
sense in terms of the organization. The only question I have is like, because like with the cargo TOML, that has like the dependencies that you're using. So when you have your own like specific smaller project within a project, how does that cargo TOML look like? Is it only going to look like related to that specific small thing, or is it going to have all the dependencies for the whole project? Because
So now
you're going to need them all to work together.
yeah, I understand your question. You are trying to ask if just one cargo.toml, which is the root cargo.toml, can have the dependency for all of them. In my case, it is possible. The answer to that is yes. It's possible to have just this root cargo.toml to have dependencies that all of these different crates uses. But in my case, I did not do it like that. In my case, each of the cargo.toml for each of the crates, I ensured that I made use of their own dependency. Now, for this transcript, I made use of Arcworks. This is a crate by Arcworks. I also made use of SHA-3. That's for hashing. Now, for the polynomial, I made use of prime field, which comes from Arcwork and ArcTest curves for my testing. I made use of Arcworks realizer and all of these dependencies. So notice that all of these dependencies, some are inside of others, some don't have their own dependency. So for each of the different crates, you can have a dependency that you are using for them. But then you can also have your root cargo.toml have all of the dependencies. So you can basically come here and create a dependency and have a particular dependency that works for all of this cargo, of all of these particular traits that is inside this workspace that serves as members in the workspace. So does that make sense?
Yeah, thank you. Thank you very much.
Okay. So Cogsy, were you asking a question before I was answering Valentine?
No, I'm good.
Okay, great, great. It's great that everyone got it. So going back, have anyone started working on the assignment?
Oh, sorry, before I asked you, you said you'll show us like how you'll set up the workspace to have those
Okay.
multiple tunnels and stuff. Thank you.
Okay. I think I should do that. So I'll just basically share my whole screen all over again just to show that. Okay, no problem, man. So to do that, I would basically uh, I would create this new folder and I would name it what do I name it? What's the name we add for it here? Library management. So I'll name it library management. So inside this library management, I would open it. And here it is. I would just bring it here. And since it's here, I would make it bigger. And inside of it, I would create the cargo.toml file. Now, this cargo.toml file would have workspace. it serves as a workspace. So let me increase this so everyone can see better. It would have workspace, then it would have members. The member, it should then be. So now it's as simple for the what's the first member? We have the leave inventory. We just say cargo new dash leave and leave inventory. So the leave inventory is added to it, and if you have it inventory, you remove this. Obviously, you remove it, and then you have it saved. Then next, have your users inside of it. Let me just saying errors like code. Just remove that. So you have your leave event. The next one is your leave users. So we're going to add leave users. Let's remove this. Let's clear this. Let's say dash leave. And we add users. And with that, oh, I added it in a very wrong. We are meant to here. So we are going to cargo add cargo dash leave users, and with that we have our leave users here, and we remove this like I did earlier, so you can have your own text. Then the next one be leave borrowing, and so yeah, so you say cargo new, then dash leave, then you can make leave borrowing, then you add that. Now you have it here. Let's also remove this. It's empty. Let's remove this also. And here we have it. Borrowing eventually users. And then lastly, we have a library app. Now the library app is not lib.rs. Instead, it's a main.rs. It's the point to application. And for that reason, we would not have it as lib app. Let's clear this. Say cargo name, and what's the library? So name it library app. And so as we can see, it has a main.rs. Others that have lib.rs. So if you look at this structure, the cargo.toml is outside, then each of it is under the library management, the lib borrowing, the lib inventory, the lib users, the lib app. So is basically inside and arrangement like this. And that's that for that. Did anyone have any question? I'll stop sharing and I'll start sharing the assignment question. So does anyone have any question based on what I've just explained on?
I'm gonna try and show you my screen, but I'm on my phone, so I need to flip it around.
Okay. So let me share in my so you can.
If you can see my I've got it like this. I don't know if this is right though.
Okay.
So like I've got like the library, and then what I did was put my terminal directory to that main library. Then I did cargo new lib app lib users. But is that the way it's meant to be?
Exactly. But why is your main.rs outside?
So like I did cargo new, so like imagine like I'm thinking the whole project is like called
No,
library.
no,
If that
you
makes
shouldn't
sense,
have
yeah.
done it like that. You shouldn't have done it like
Okay.
that.
So
All
what's the
you had
console command for that way?
all you have to do, it's not a so and all you have to do is to create a folder, name it whatever you want to name it. Now in our case, we are naming it library management in our case. And so for your library management, you're naming it, then you would have to create the file.toml yourself. Let
Okay.
me share. So you will not use
Okay.
a command to create that cargo.toml yourself. You will have to create that cargo.toml by yourself. So
Okay.
notice
Okay.
I myself one one. Yeah. This cargo you have to create it yourself. You have to create it by yourself, and you and write you call it this web, then you create member, and then you don't have to create members. All you have to do is create workspace. Just type inside this web, then you then start by all of your by saying cargo dash 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 keep whatever name you want to name it, just like this. So
Okay.
that is
Do you think you could add to the Google Doc like kind of like that step by step? It's just that you're cutting out a bit, and I understand what you're saying, but I just can't, get the whole thing when sometimes you cut out.
okay. Just to make it easy, here is how what you would. I would want you to go through this on the slide. This particular part that says no, it works. So you follow the instruction. Start by
Okay.
HTML in the root. So once you create it, just the file inside the file you name. Then all you have to do is then have to create each of the dependency by adding the in your terminal new dash sleep, but the name of which you want to add to it is. So
Ah,
I'll
yeah. Thank you. I
drop
see that now. Yeah.
this here again. So you have that. So thank you very much, everyone. I will be expecting to see everyone's solution on Thursday. Because we definitely want to, go through everyone's solution before we start checking out the solution for the assignment from my end. So everyone, please do well, do it. It's knowledge on how, because at the end of the day, why are you learning? Why are you? It's obviously to work with a firm or to build your own product. And when you are building a big infrastructural product that will be used by many, it's definitely not going to be a simplified one like what we are. But the building blocks in a very large project or a very large project is workspace that I have just introduced. And so you definitely get the recordings to this lecture. So the important is, having to be able to do it yourself at the end of the day. And that's definitely what will give me much joy when you are able to come and myself, to build this product, able to join this firm. And when you join the firm, your workspace is quite large, space is quite large, but all of it is organized inside this workspace. So stop the recording now, and I would like to thank very much everyone for participating. I really appreciate all of the questions that was asked, and it basically encouraged me myself